Hello and welcome to sixth lecture in chapter number 7 of our comprehensive course on AI, machine learning and data science. Now, name of this chapter is data wrangling with pandas. And so far we have done these things. How to handle missing values using pandas, pd.fill.na or data frame.fill.na, then data type conversion where you can write df, then in a square bracket the name of the column in quotes, of course. For example, the name of the column is product, then df in quote product, square brackets over, and then write as type in small parentheses. You can write whatever type you want. For example, if you want integer, then write as type int, or if you want floating point, then write as type float, like that. Okay, so that is how data type conversion we had done. Then outlier detection. Now for outlier detection, usually strategies are created based on the given data set. So there are no hard and fast rules, but some around those points which are beyond 1.5 times the standard deviation from the median on its either side, upper or lower side, they are considered outliers. But there are several techniques for handling outliers. Similarly, there are several techniques for handling missing values. You can put median, you can put you can put mean, or you can put the mode, that is most frequent value, if it is a categorical variable. But these are only three basic techniques. We saw a long or a big diagram in which at least 20 to 30 different techniques are there for handling missing values. But I also said that most of those techniques are only required at the research level. Same outlier detection also has several techniques, but again we will mostly stick to that 1.5 times the standard deviation, and other techniques are required at research level. Now last topic which we did in previous lecture was this: duplicate detection and deduplication. How to find the rows which are duplicated. Either over all columns the values of features in two rows are same, or over a given subset of columns the values of features in the two rows are same. So that much we have already done in previous lectures. Now we want to do this thing: identifying and dropping single valued columns. Now it is clear that if a column has only one value, then such a column which is not variable at all has no effect on the final outcome. So they will not contribute to the predictive power of any analytical model. As a result, it is better to simply drop that column. So we are taking some example of that. Then you will realize why they do not have any contribution to the predictive power. For example, let us take this case. Yes, identifying and dropping single valued columns. Now, for example, I have this kind of table in which I am studying the effect of these three variables: age, education, and gender on income. So it is a kind of income analysis, and I want to see how a person's income varies with age, education. Education means years of schooling. So 12 years of schooling means standard 1 to 12. 16 years of schooling will be 1 to 12 plus 4 years degree. 18 years of schooling will be masters, like that. Okay, so how education affects the income, how age affects the income, and how gender affects the income. But unfortunately the data which I have is like this. Okay, I have shown only 5 rows, but in other all maybe there are 10,000 rows, and in all rows the gender has male, male, male only. Now that gender is not varying at all. So can I study the effect of gender on income? No, because all genders are male. So that means that gender is not a variable, it is not a feature. Otherwise, basically data science is nothing but developing a equation which relates your response variable, or which is also called dependent variable, and your features, or which are also called independent variables. So if this is x1 age and this is x2 education, then I want, and this is y the income, then I want some equation that y is equal to some constant multiplied by x1 plus some other constant multiplied by x2 plus some other constant multiplied by x3 gender. But unfortunately gender is not a variable, it is already a constant. So everywhere for all 10,000 records gender is male. Then that kind of for that kind of data set we say that income variation with gender cannot be studied, or that means that gender does not contribute anything positive because it does not contain any any information at all. All genders are male, so there are no female or there are no other genders. So in that case you cannot study effect of gender on income, so you better drop that column. Such columns which are single valued column, that are always simply dropped. There is no complication that substituting median value or mean value or mode or anything, or maybe some sophisticated substitution technique, nothing doing. Simply drop that column, because that is not at all a variable, that is a constant. It is not a useful feature. Now, as I said, I can make this kind of equation: income is equal to beta 0 plus beta 1 multiplied by age plus beta 2 multiplied by education plus beta 3 multiplied by gender. But unfortunately, what is happening is gender will not vary at all. So I want to study that if gender changes from x to say maybe x1 to x2, then how income changes. But gender is not changing at all, so the change is 0. And if change is 0, then that means change in corresponding change in income will also be 0. So remember, for every model, the absolute values of the features are not important, but it is the change in this feature, that if age increases by 5 years, by what amount the income increases correspondingly. Or if education increases by 4 years, that is, instead of 12 years of only schooling, a person finishes the college, 16 years of education. If education increases by 4 years, what is the corresponding increase in the income? That is what we want to study. But here, if gender changes by what? It is not changing at all. So then there is no question of corresponding change in the income. So last term in the equation is redundant, as gender does not vary. And at such column can, if you keep that column, it can lead to incorrect assumption and inefficient model training and prediction. It also wastes computational resources and lead to bias in the model's outcome. Because a model is not to be used only over a given data set. Once such equation is obtained, then you have to use it over a known data set. Now, over an unknown data set. Now, suppose in unknown data set, a new entry comes for which the age is say 23, education is again 12 years, and gender is female. But your model is already biased. It thinks that only the male gender has some income, female gender, then it is not at all trained for that. So it will give some absurd result. Okay. So it is better to remove that kind of column. Okay. Now let us create that kind of column. Again, remember, this is not part of some solution. So you should not bother about the code. As such, code is very simple, very elementary, but I am just creating an example data frame. Okay. And earlier this used to be a problem for course creators or book authors, that when they use the data, you will be surprised, but in European or US or British jurisdictions, you have to take permission for even using someone's data. So you cannot just copy paste the data from one book or from one website like that. So now with the ChatGPT and other tools, I just create my own data. Here not even ChatGPT is used. I am using a simple dictionary method. So this is my dictionary. These are the keys, and we know that the keys will become the column headers, and these are the values. And we also know that the values will become the rows in below the columns. Okay. So product ID changes from range 1 to 51. Fixed value changes from using np.repeat. Now this is one interesting. So far it has not come. Others are all known to you. But repeat. So we will see what it does. Okay. This, what is the meaning of this 100 and what is the meaning of this 50? Then np.random.rand, that we have done that, it will create random integers between this minimum value and this maximum value. And how many random integers will be created? 50. So that will decide the number of rows, 50. Okay. Similarly, this will also size 50. It will create random integer between 18 and 70, and 50 rows will be created. This is also actually number of rows only, and only 100 will be repeated, because I want this kind of column in which same values is repeated. So np.repeat is just a simple thing. Same 100 would be repeated in 50 rows for the column whose name is also indicative fixed value. And these are also 50 rows, because 1 to 51. So that will include 50 rows. And then you can write product ID. That will become something like a unique index. Okay. Now, once such dictionary is created, you have to just use pd.dataframe, D capital and F capital, remember. Okay. So in that case, and in bracket, you have to specify that dictionary. So that will create the data frame, and we can print that data frame. So this kind of data frame is printed. 50 rows are there. So only head is printed here. That is why only top 5 rows are there. But suppose I print entire data frame. In that case, you can see this is that entire data frame. And see this fixed value column. It has 100, 100, 100, 100 everywhere. Okay. Sales, customer age, they vary, but fixed value. And see the product ID column also. That product ID changes from 1 to 50. Okay. So that is fine. Now identify which column is single value, because as I said, every time it is not possible to print the output like this and visually decide that this column is single value. What if this has 1 million row? Then it is possible that first 100 rows or 50 rows have same value, but maybe 2051th row that has 200. So then that will not become a single valued column. So you cannot visually decide, you have to programmatically decide. And programmatically deciding is very easy. Column for column in df.columns, if df column dot n unique equals 1, because what this n unique does, that we have already seen earlier. N unique gives the number of unique categories in one particular column. For example, if I write that df in square bracket product id in quotes square bracket over and then n unique, then it will give me total 50, because each and every product id in all 50 observations is unique. Okay, so let us do it and see if it is giving or not. So df then product id, let me check the spelling, because of spelling where what is capital and what is small and all that. Okay, so product id dot n unique, and if I say 50, because each and every row is unique. Now similarly, instead of product id, now I will write fixed value, so that will give me that will give me how many unique values are there in the fixed value column. Okay, so dot n unique, that will give me 1. That is because that has only same value being repeated in all rows. Then similarly, as such, this much is enough, because suppose I am knowing that there is only one column which is having all values, but let us check other columns also. Then sales, and other column is customer age. Okay, so here now the column name is changed, it is sales, and control enter, 48 unique values. Total 50 rows are there and 48 unique different values are there. So that means that that is not a single valued column. Okay, and last is this, that here customer age. Okay, fine. So customer age and control enter, that also has 34. So when you use this, then it is clear that you are getting that first product id has all 50 unique values. So obviously it is not single valued column. In fact, there are 50 rows and 50 unique values. So each and every value is unique. But fixed value column has only one unique value. So that means in 50 rows, I could find only one value which is unique. So that means that is a single valued column. Here in 50 rows, there are 48 different values. So most of the values are different. Maybe 2 values are here and there are repeated. Then here in customer age, 34 values are unique. So 16 values here and there are being repeated out of 50. But I cannot say that customer age is a single valued column. Okay. Now I cannot afford to do this way for each of these column one by one. So you have to use the for loop for this. We usually use for loop. Then of course later on in the next cell, sorry, what has happened? Okay, what I was saying is that I cannot afford to check like this, that for each column one by one. I can use a for loop like this, for example, that for column in in what, then in which data frame it is, df dot columns. Okay, so in df dot columns, then I will put a colon, and so next line will be automatically indented. Then what I have to check, if df column column is equals dot n unique equals 1. Now if also is followed by a colon symbol, then that column is a single valued column. So maybe in the beginning you can initialize one array, single this array, actually single valued columns. Okay, and keep it an empty array. So if this condition is satisfied, that unique categories are 1, then single valued column, that array dot append the column. Okay, so the name of that column you should append in that. Else do nothing. Okay, and finally when your whole loop is over, then return single valued column. So this same logic which is being done by the for loop here, that is we we have already learned that the small method of doing that is list comprehension, and list comprehension is written in this manner. List comprehension is a fit case when you want to fill up some list. So here I have this empty list and I want to fill it up. So whatever you want to fill it up, that comes on the left side, is equal to, then in the list comprehension, so obviously I want to create a list. So first thing is create a list. So the beginning square bracket and the ending square bracket. I hope that it is clear. Then leave some space here, okay, and start writing your for loop. For column in df dot columns, then write condition. If df column dot n unique equals 1, then add that column to your list. That's all. So everything which you are doing, that is being done by just one single line. Okay, we have done a very detailed discussion about list comprehension in one of the earlier chapters. So if some of you have lost the memory a little bit, then please refer. Okay, so it is giving only one column fixed value because other columns do not satisfy the condition that there is only one unique value. Okay, now next step is drop these columns. Now dropping this column, dropping a column is always done by df dot drop, and in bracket what you have to write is which columns you want to drop. This df dot drop column can drop either a single column or it can drop several columns in one go. So what you have to write as the first argument, columns equals, then you have to write a comma separated list of all columns which you want to drop. So here this is actually the single valued columns is actually my list only. Unfortunately or fortunately, whatever, I have only one one column which is single valued. So that's why my list contains only one. But it can, suppose this data frame has some other column also which is single valued, then here that fixed value and another column will be fixed value 2, and here a comma separated list will be there, that will be fixed value comma fixed value 2. Okay, but that is this list in this case. So I am specifying that list, and this time I am writing in place is equal to true. Now in previous lectures we have done this discussion that when you do the this in place is equal to true, your data frame is modified directly. Okay, now there is another option. If you don't want to write in place is equal to true, then you can here write df is equal to df drop. That means this change whatever occurs and whatever new data frame is obtained, please assign to the old data frame. So old data frame is changed. Okay, both ways you should get the same result. So what I am doing is I am first let me print the output of this. So you can see that the column has, that fixed value column has been dropped from this, and only head I am printing. That's why first 5 rows are getting printed. Okay, so that fixed value column which had same values. Now let me show you that instead of this I can also do that other things, but for that I have to recreate my original data frame. And this time what I was saying is, if you don't want to write in place is equal to true, then first let us see, if you don't write anything and just write it this way, then what happens? Then your that fixed value column remains. Okay, when you print df dot head. So that means what is happening, this dropping is not being successful. It is being successful, but it is temporary. As soon as the control moves to the next line of code, that dropped values, I mean that new data frame which is created by this line, that is just released or thrown away, you can say. But I want to store that data frame here like that. So one method was this, that put in place is equal to true. Other method is this, that assign the value after dropping back to the original data frame itself. And then if I write, then you can see that that is also giving same result. So you should prefer any one method, but you should know both methods. Okay, because when you read someone else's code, then you should be able to follow. Okay, now this is one very important point. This is just explanation which I have given, but this is one very important point, that it is not enough to check for single valued column in the beginning of our exploratory data analysis. When we are doing the data manipulation, we do a lot of things. Sometimes we group various rows. Sometimes we divide a data frame into 2 data frame vertically splitting. Sometimes we divide into horizontally, that is H split, vertical V split, and all that issues. So that may create something during the process when you do group by or some that kind of operations. Then it is possible that a new single valued column may come into existence as a result of those steps. Okay, so this is a very good example of that, and therefore such checks for single valued column, this line, this list comprehension by which we check, they should be done some periodically during your exploratory data analysis, and particularly you have to check this just before encoding, and just that is encoding is converting the string and categorical variable into numbers, because I have repeatedly said that machines only understand, computers only understand numbers, so you have to have all columns in the number form. Before that you should check this, and before feeding your data into some model, you have to check this again, because see here what is happening. This was my one data set. Let me magnify this slightly. So year, quarter, month and user. So you can see that year is 2019 and quarter is Q1, 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 but Q2 and Q2 are also there. So that means it is 2019 first quarter and second quarter's data. Then month, January, February, March, April, May. So this is not, that means each row is unique. You can see that the quarter is same, year is same, but the months are different. Okay, users for that month, for that firm are in according to this. Similarly, this is another data for that same firm, ad partner. So I am just evaluating the effect of two ad partners which I have attached with my firm. In some quarter I assigned my job of advertising to this ad partner, and in some quarter 2020 first quarter I assigned the job to B ad partner. Okay, and I am planning that which ad partner gave me more customers or something, that kind of analysis. Okay, but suppose during the process of analysis you needed to merge these two columns. Okay, and merging is being done on not single column year or single column quarter. Merging can be done only on column common columns which are there between the two data frames. So here this much is my one data frame, and this much, this is another data frame. So on the left side of arrow there are two different data frames, and I want to merge them. So I can merge them on year and I can merge them on quarter, because year and quarter are common in both data frames. But I can also merge on combine key. Okay, that is year plus quarter. So let us try to merge that way. But if you merge in that way, that the resultant data frame is shown on the right side of column. Now you can see that at that moment what is happening to the ad partner, that this combined merging will keep only those rows which are common to both the data frames which are being merged. So on the left side these are data frames which are being merged, but this row with B ad partner will not be kept. Why? Because there is no corresponding row, that is, or say this 2020 Q1, but here there is nothing 2020 Q1. This is 2019 Q4. Here there will be, okay, that is also not there. 2019 Q3, that is also not there, and then 2019 Q2, 2019 Q1, they are there. Okay, fine. So ultimately only Q3 will not come, and this Q2 will not come. Only 2019 Q1 and 2019 Q2, that two will come, because they are in both the data frames which are being merged. 2019 Q3 will not come because here there is no Q3. 2019 Q4 will, that whole row will also not come, because here there is no Q4. Okay, and 2020 will also not come because here there is no 2020. So as a result, many rows are just simply removed, and common rows whichever are there, they are coming. So when I say that 2020 row is removed, that means B is also removed. So when I say other rows are left, only rows with ad partner A will be left. So what is happening? I started my analysis like this. I made a merge on multiple columns, but as a result, I got one single valued column. This did not have any single valued column. These also did not have any single valued column, but after merging, a single valued column arises. So data pre-processing, like operations like group by, merge, they create such single valued columns. Now here I have shown by diagram, but here this is the same thing shown by code. Okay, so I have created first a data frame. Again, the method is very simple, that whatever are the column headers, they should be keys. So year, quarter, month, users. This is the first data frame. Whatever are the values, they should be the values, and more than one values are there, then they should be specified as a list. All these have 2019, so list has only 2019. Fine. Then quarter, all these have Q1, 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 but 2 have Q2. So Q1, 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 and 2 have Q2. And then month, it has January to May. January to May. Users, each value is different. So here also users, each value is different. Fine. So this will create the first data frame. Let us check it exactly created or not. Then yes, it is exactly this kind of data frame. Let me now minimize, okay, and bring it to normal. So then you can see that it is exactly that data frame. Similarly, let us create the second data frame. Okay, let me do one thing, that I will paste one just for visibility, and I will paste this image here also, just so that it is easy to see. Now I am creating this data frame, so that has three columns: year, quarter, add partner. They will become the key values, keys for the dictionary, and this has 5 rows: 2019, 1919, and last 20. So they will become the comma separated list of values. Quarter, Q1, Q2, Q3, Q4, and again Q1, they will become the comma separated list of values for quarter column. And add partner, all A's except the last, which is B. So all A's except the last, which is B, that will be comma separated list for add partner. And if I execute, I am getting the second data frame. Now I am merging. For merging, the command is as such, this merge and all that will come later on. Here we are just doing data wrangling with pandas, and our purpose is to see how to tackle the single valued column. So here this does not have any single valued column. The second data frame also does not have any single valued column, but I am doing a merging on two columns combined, year and quarter. Okay, so merging is always done by this very simple syntax, that pd.merge first data frame left side, second data frame right side, and list of columns over which you want to do your merging process is given by on is equal to. If you don't give this command, then it will take whatever is the now here there is a problem because there are two columns, but if normally there is only one column common between them, then it will automatically take on that one common column. But here two columns are there, then you have to clearly specify that I want to do a combined merge. And how? Then how is equal to inner. Now this discussion, that various types of joins, those who are coming from SQL background, they know that inner join, left join, right join, full outer join, then maybe I think inner join, that is itself full inner join. So that type of joins are there. Those who are not clear, don't worry, because we are going to take this merge in much detail later on. So inner join, when you do, then at that time only the rows which are common in both of them, they are kept. So as a result, I showed that this row will not come because 2020 is not there anywhere in this, so it is eliminated. This row will also not come because Q4 is not there anywhere in this, so eliminated. This row will not come, Q3 is not present anywhere, so it is eliminated. This row will come because 19 and Q2 is there, okay, and this row will come because 19 and Q1 are also there. So the original 5 rows plus 2 more rows, like that, okay, but they are exactly common. So these and these are exactly identical, and similarly these and these are also these and these are exactly identical. So they will just be placed there, and you get rows which has only 2019 and Q1 or Q2. So this is how inner join can be performed. So let us perform that inner join, and when I perform that, that issue is created. Okay, that this column has single valued, this is now becoming single valued column. So what you can do is, you can again check for that identify single valued column, so and then drop them. So using list comprehension, so single valued columns, which is a list of column names, is equal to column for column in df. Now instead of df, what is the data frame's name here? Result of merging, right? So result dot columns, if result column dot n unique equals 1, that will give me single valued columns, and print a single valued column. Unmatched, what is the problem? I think, yeah, here this is not required. If result dot column, correct? No, this one. Yes. So you can see year and add partner, these two have become single valued column. So now I have to drop those two both. Whether it is feasible for your analysis or not, that is a different matter. But if you want to drop them, then you have to drop them by this method. Okay, that drop single valued column. So that means here I can write, instead of df result, say I will write result new just for distinguishing, is equal to result dot. Actually, giving new names to new data frames is not a good practice. You have to store things in original data frame only. But anyway, drop columns equals single valued columns, and df dot head, instead of that, results new dot head. Okay, and control enter. Okay, so result new, not results new, but result new. So now only three columns are left. This is also gone here, and add partner is also gone. So the point is that sometimes single valued column may not be present in your data set right from the beginning. The original two data frames were looking very innocent here. One was this, no single valued column, and second was this, no single valued column. Here, sorry, this was first and this was second. But when I did a merge on them, inner merge, which is like inner join, then I got two single valued columns, and therefore I needed to drop it. So the checking for single valued columns should be periodically done during data pre-processing, and it must be specially done before you do encoding, or before you feed your data to your machine learning algorithm. Okay, so that was one thing. Now the last thing in the data wrangling, name of this chapter is data wrangling with pandas, and we have done many things. Now this is the last thing, normalizing and standardizing the data, and we will do that in next chapter. Thank you.